when you're given a differential equation of order 2 or more, you can change it into system of first order differential equations by coming up with new functions y1, which is same as y, y2, which is same as y prime, and so on. Now the basic rule is that if the order is 3, then you would need 3 of them. If the order was 4, then you would also define y4 as the third derivative of y. But since this is third order, we just have this much. Once you have this, then you have to ask the following question. What is y1 prime? What is y2 prime? And what is y3 prime? Because when you write down a system of first order differential equations, your goal is to rewrite these as some mix of y1, y2, and y3 with some coefficients. And moreover, because this is a non-homogeneous differential equation, this 2t cubed should be appearing somewhere. Okay. Alright, so y1 prime. If you take y1 and differentiate, what do we get? If we take y1, differentiate both sides, then you get y prime. But what is y prime? That's just y2. And let's do the same thing. Take the y2 equals to, take the y2 equals to y prime and differentiate both sides, and that gives you y double prime, but y double prime is y3, so you just write y3. However, things are a little more complicated when you take this one and differentiate. You have y3 prime, that's y triple prime, right? And y triple prime, unfortunately, is none of these. It's not that simple. You have to see that this actually goes here. And of course, you have to use the original differential equation at some point, and it always happens when you differentiate the last one. Okay, so we take this and we have to solve this for y triple prime, because y triple prime is what's appearing here. So let's do that. We solve for y triple prime by first moving the negative 2ty prime. So moving the 2ty prime to the other side so that it becomes negative, still plus 2t cubed, and then divide by 2, you get y triple prime equals to negative t y prime plus t cubed. So that's perfect. However, again, you're not allowed to have any derivatives on the right side. See, when you write down a system of first order differential equation, it should always have this format: y1 prime, y2 prime, y3 prime equals to something where on the right side you're not permitted to have any derivatives. And because y prime is there, you have to replace this by something that does not have any derivatives. And what could that be? Because y prime is y2, you can replace this by y2. And that's what you have, negative t y2 plus t cubed. And then finally, because y1, y2, y3 is, it becomes a single column vector when you write this into a system of equations. This thing can also be written as this column vector evaluated as 0. So this evaluated as 0 is what? That's y of 0, y prime of 0, y double prime of 0. So those values should be 2, negative 3, and 1. So that's what you have. You have the system here with the initial condition that y1 of 0 should be 2, y2 of 0 should be negative 3, and y3 of 0 should be 1.